Good morning, students. Today in this lecture, I am going to explain you about the topic of properties of coal and overfeed and underfeed fuel beds. Myself is K. Pradeep Kumar, Assistant Professor in Mechanical Department, working in MVR College of Engineering and Technology. Coming to the topic, what are the properties which we should consider when we are using the coal in different ways where we require this coal in the power plants. And in the topic, we are going to discuss about overfeed and underfeed fuel beds of coal in power plants. These are some of the properties which I have named here, the properties of coal. That here the first property is about swelling index, grindability. The third one is nothing but of weatherability. The fourth one is about sulfur content. The fifth one is about heating value. And the sixth one is ash softening temperature. These are the main properties of coal which we are using in thermal power plants for getting the electricity. See, we can study these properties of coal one by one in a detailed manner. See, first of all, when coming to swelling index, some types of coals during and after release of volatile matter become soft and pasty, forming agglomerates. These are known as caking coal. See that some types of coals after releasing of volatile matter. See here, the volatile matter means nothing but of. We can observe here that the volatile matter means are the methane, hydrocarbons, hydrogen, and carbon monoxide, and incombustible gases like carbon dioxide and nitrogen found in coal. Thus, the volatile matter is an index of the gaseous fuels present. See here, we can clearly observe that volatile matter means nothing but of these gases which we are having, these methane, hydrocarbons, hydrogen, and carbon monoxide, and incombustible gases like carbon dioxide and nitrogen found in coal is nothing but of a volatile matter. Coming here, that some types of coal during and after release of volatile matter means after burning of the coal, we are getting some volatile matter output or outside become soft and pasty forming. Means the coal after burning of the coal, we are getting the output as volatile matter in the what I have shown or what I have told you about the volatile matter, that the hydrocarbons, hydrogen and carbon monoxide and incombustible gases like carbon dioxide and nitrogen found in coal are nothing but of these volatile matters. After burning of this coal, the volatile matters which are coming out from the coal is nothing but of soft and pasty in the formation which we are naming this as agglomerates. The pasty form and softy form, which when the coal is going to form in soft and pasty form, we are naming this as a caking coal. We are naming the form as a caking coal. Coal that does not cake is called free burning coal. Means when we are going to burn the fuel, when we are burning fuel, some coals are going to get the volatile matter outside after burning of the coal. Some coals does not release the volatile matter. When the coal does not releases the volatile matter here, we are naming that the coal as free burning coal. When the coal is going to get a volatile matter and become soft and pasty, we are going to name these as agglomerates. And we are simply naming these in the form of agglomerates, and we are naming these in the form of a caking coal. Simply, I have explained you about the volatile matters which comes out from the coal. See here, we can clearly observe that volatile matters are the methane, hydrocarbons, hydrogen and carbon monoxide, and incombustible gases like carbon dioxide and nitrogen found in coal. Thus, the volatile matters is an index of the fuels present. Thus, the volatile matter is an index of the gases fuel present here. The typical range of volatile matter is 20 to 35%. What is the volatile matter which is coming out from the coal after burning of the coal is about 20 to 35% here. And volatile matter means the proportionately increases flame length. This volatile matter proportionately increases the flame length and helps in easier ignition of coil, sets minimum limit on the furnace height and volume, influences secondary air requirement and distribution aspects, influences secondary oil support. See, coming to here, the first property which we are studying is about the swelling index. Swelling index is a qualitative method used to determine the extent of caking of a coal. Means extent of caking of a coal means it is going to extend the caking of a coal. The caking of a coal means nothing but of what I have said you there, that when we are going to burn a coal, it is going to get some volatile matter out. Means which we are extending is nothing but caking of a coal is nothing but of a swelling index. See here, a free burning coal has a high value of swelling index. That I have told you that some coals does not get this volatile matter out when we are going to burn a coal. Such that when we are not getting this volatile matter out from the coal, we are naming this as a free burning coal. A free burning coal has a high value of swelling index, which indicates that it slightly expands in volume during combustion. Means swelling means nothing but of, we know that it is going to increase the size, it is going to increase the volume of the material or the product which we are taking here. See, free burning coal has a high value of swelling index means the coal which is not getting a high this volatile matter out is having swelling index means having high volume, means which indicates that it slightly expands in volume during combustion. When combustion has been takes place here, when combustion has been takes place or when combustion is going on, when we are burning the coal for free burning coal, swelling index does not get. This is nothing but of a swelling index which we are studying in the first property of a coal. This swelling index is often important for pulverized coal. This swelling index is most often or most important for pulverized coal. Pulverized coal means nothing but of which we are breaking the coal into small pieces. Since The first property we have studied very well and explained in a detailed manner, that what is meant by a swelling index. We can understand in a simple way that swelling index means nothing but of extent of caking of a coal, means which we are enlarging the size of a coal. This free burning coal is having a swelling index more than that of the others. Simply, it is very important in a pulverized coal. Coming to the second property, the second property which we are having here is nothing but of grind ability. The grind ability is one of the important property in selecting the coal. Property means by using of the different properties, we are going to buy the coal. By checking of the properties of the coal only, we are going to get the coal. And by using the coal is one of the most important product which we are using in the power plants. See here, this property is measured by standard grindability index, and this grindability index is inversely proportional to the power required to grind the coal to a specified particle size for burning. See here, in the name itself, it is mentioned that we can observe, or we are going to get some idea that grindability means nothing but of breaking of the coal into small pieces. Means here the grindability index is inversely proportional to the power. It is acting as inversely proportional to the power required to grind the coal. For grinding the coal and converting into a particular size which which is used for burning of the coal, or which is used for getting hot gases to uh, to heat, or to get the feed water converted into these saturated steam or superheated steam by burning of the coal, which is most importantly used in the boiler section in the power plants. This is about the grindability, that which we can grind these coal into small parts. And coming to here, the third property which we are studying is about weatherability. Weatherability means in the definition itself or in the heading, by using of this, we can tell that by using the weather conditions, we are going to get some deformations, and it is a measure of how well coal can be stored for a long time without crumbling to pieces. Means due to weather conditions also, the coal can be decreases into small pieces, and it can be crumbled into the small pieces, and due to weather conditions the coal is going to be decreased by getting more air. Generally, modern power plant stores coal supply of 90 days in large. Means in totally the store, what is the coal which we are getting from outside, and where when we are storing this coal in the power plant, the coal which we have stored in the power plant can be used maximally in 90 days, and getting a new coal means getting a and we can reusable this coal in a very quick manner, and we are going to complete this coal in 90 days itself. Means the weatherability is telling that due to weather conditions, the coal which we are stocking is much more than that, crumbling into a small pieces, and the coal is going to be decreased. This is about the third property which we are studying about the weatherability. Coming to the next property, and here we can observe some more points about the weatherability. Ever since crumbling of coal due to climatic condition may result in small particles of coal which can be carried away by wind or rain. See here in this line we can study that by using by getting of rain or by wind, the coal which we are storing outside in the outside yards are going to be disturbed, and it is going to be dipped into the this land itself, and it is going to be crushed into a small pieces also when we are getting more wind and in rainy seasons. And coming to the sulfur content which we are using here in the coal, the sulfur in coal is combustible and generates heat by its oxidation, forming S2. SO2 is very essential during combustion. Sulfur in coal, that what is the sulfur which we are using in coal is combustible and generates heats. The combustible, the sulfur is going to combustible and generates heat by its oxidation forming. And this SO2 is very important for combustion of this coal. It is a major source of air pollution, and when it releases into the air, it is going to this so sulfur is going to pollute the air also. And coming to the next property which we are using or which we are studying is about heating value per calorific value of coal. That this property is of fundamental importance. It is the heat transferred when the products of complete combustion of sample of coal are cooled to initial temperature of air and fuel. See here, by studying of this point, we can understand that it is the heat transferred. Heat is transforming when the products of complete combustion of sample of coal are cooled to initial temperature. That when we are going to cool this coal up to the initial temperature of air and fuel is nothing but of heating value of heating value of this coal. See, this calorific value is generally we can determine by the bomb calorimeter. This is about the calorific value. And coming to the next property, we can study about ash softening temperature. The ash which is generating out or the ash which is coming out, the ash which is coming out when we are going to burn the coal from the coal grade, ash softening temperature. The ash softening temperature is the temperature at which the ash softens and becomes plastic. Here we can observe here that what is happening here, that the ash which is getting is going to soften here, and due to some temperatures the ash is going to softens and it is going to become into a plastic formation. This temperature is slightly less than melting temperature of ash. The temperature which is generating here is nothing but of temperature is less than that of the melting temperature of an ash. This ash softening temperature is an important factor in designing a steam generator. See here, it is a very important fact that this ash softening temperature is used in designing a steam generator. Steam generator means nothing but of the turbine that which we are using in a Rankine cycle as a second topic, which is used very majorly as a main product in the Rankine cycle to get the output, and the steam enters into the turbine and um, expands the steam and is going to get the work output. Such a For getting such type of a turbine or steam generator, the ash softening temperature is very important here. For a furnace that would discharge ash in solid form, a high Ash softening temperature is required, otherwise clickness would be formed. For a furnace that would discharge ash in solid form, that a furnace is going to discharge this ash softening temperature in a solid form, and this is used for required for clickness, and this is used in the form of ash formation. It is difficult to remove the clickness resulting in efficient combustion. See, it is difficult to remove these in inefficient combustion processes. These are the six properties which we are going to study here clearly. See, up to now we have studied the properties of the coal, about the swelling index, how the swelling has been formed in the coal, grindability. Grindability means which is going to make particles into small particles. Weatherability, due to weather conditions, how the coal is going to be. And in sulfur content, by adding of the sulfur content, what is happening there. And by using the heating value, what is happening due to the coal which we are using here. And air softening temperature is used morely for getting of these steam generator. These are the six properties which we can study very interestingly for getting the coal. And coming to the next topic is about overfeed supply of coal. When we are going to overfeed the coal for burning and for getting of heat to the boiler, for converting the feed water into the superheated steam or dry saturated steam, we are going to overfeed our supply of coal. Means we are supplying more than the coal which is required there to convert this feed water into dry saturated steam or superheated steam. We can clearly hear the when we are going to observe the diagram, we can clearly understand the how what is happening if we are going to overfeed or if we are going to supply more coal here. In case of overfeed stroker, coal is fed onto the grate above the point of air admission. See here what is happening here. Here we are having the grate. Here we are having the grate, and we are supplying air into this grate. See here, this is the grate, and we are supplying the primary air into this grate. Through this grate, the air is entering into the upon to the grate, and the coal which we are having here is burnt by using of this air. Um, we are going to we are going to heat this coal, and some ashes has been formed here. And after that these gases are going to be formed here, and after burning of this coal, we are going to get these gases as output, and incandescent coke has been formed here. And here we are using the green coal also. After burning of this coal, we are going to get the gases here, and the secondary air is going to be supplied here. And by using of this secondary air, the heat again the heat is going to be generated in a flame formation. After, when it is going to be entered into the atmosphere, what are the gases we are getting out is nothing but of CO2 plus O2 plus N2 plus HO2, which we are used in the secondary air formation for getting the heat here. We can clearly understand one by one in step formation about this overfeed supply of coal. Here, first of all, the pressurized air coming from FD fan enters under the bottom of the grate. See, we can observe here that what it is telling in the first point. In the first point itself, it is telling that the pressurized air is coming from FD fan enters under the bottom of the grate. Enters under the bottom of the grate. This is the grate, the air which is entering into the under the bottom of the grate here. And here the air passing through the grate is heated by observing the heat from the ash. See here, the air passing through the grate is heated up by observing the heat from the ash. See here, the air which is coming from the grate is observed by the ash. Here is heated by observing the heat from the ash. What is the heat which is getting out from the ash? By using of the heat which is coming out from the ash, the air is heated here, and grate itself, heat from the ash and grate itself, whereas the ash and grate are cooled. When these air moves upwards with this heat, whereas the ash and grate are going to be cooled here. The hot air then passes through a bed of incandescent coke. See here, the hot air after this ash entered into the incandescent coke. As the hot air passes through incandescent coke, the O2 reacts with C to form CO2. See here what is happening here. We can observe clearly in the diagram that when it is and the air when entering upon to the grate, the ashes which releases the heat observes the heat coming out from the ashes. The air enters into the incandescent coke here, and it reacts with the O2. O2 reacts with C to form CO2. Generally, for a fuel bed of 8 centimeters deep, all the O2 in the air disappears in the incandescent region. The gases leaving the incandescent region of fuel bed consists of, see here, what are the gases which we are getting out is nothing but of Vm plus CO plus CO2 plus N2 plus HOT. This is, and the raw coal is continuously supplied on the surface of the bed here. Here it loses its its volatile matter by distillation. By using of this distillation, it is going to be lost its volatile matter. The gases leaving the upper surface of the fuel bed contains combustible volatile matter formed from the raw fuel, what I have shown you in the figure. Additionally, secondary air is supplied at the top of the bed to burn the remaining combustible gases. Here we are adding here the in the diagram itself. We can observe that we are adding here the secondary air also. Here, additional secondary air is supplied at the top end of the bed to burn the remaining combustible gases which is remaining, such as volatile matter plus CO2 plus H2. The secondary air is supplied at a very high speed to create turbulence, which is required for complete combustion of unburned gases. See here, the secondary air which we can observe here in the diagram is used for unburnt gases, and it is completely used to burn the gases here, unburned gases here. The burned gases entering boiler contain N2, CO2, O2 and H2O, and some CO if the burning is incomplete. This is about the feed, what we have studied here, that which we are feeding here, here to the coal. Overfeed supply of coal, which we have studied up to now in this topic. And coming to here, underfeed supply of coal. In this type of stalkers, the fuel and air move in the same direction. Means we can clearly understand in the underfeed supply of coal. We are feeding here the what we are feeding here, the fuel and air is feeding here, and the fuel and the air moves in the same direction. In the same way, what I have said you in the before diagram and what I have explained in the before diagram, we can observe clearly that primary air is entering through these two holes. The two holes which we are having here, the two holes. By using of these two holes, the primary air is entering here, and here we are using a green coal here, and it enters into the after burning of this coal, some ashes are going to be formed, and it enters into the incandescent coke, and here we are using the ash, and again we are supplying secondary air, and the unburnt gases are going to be burnt by using of the secondary air, and the gases which we are getting out is nothing but of CO2 plus O2 plus N2 plus HO2, which we can clearly understand, and we can study clearly the in point wise about the diagram which I have showed you now, that the mechanism of combustion in underfeed stoker is described below. That air, after passing through the holes in the grate as shown in figure, meets the raw coal. See, we can observe here that what he is saying in the first point is about air after passing through the holes in the grate as shown in figure meets the raw coal. See here, the air which is entering here is going to meet these raw coal which is placed here. The heat for distillation comes by conduction from the mass of incandescent fuel bed which exists above the raw coal. The air mixes with the formed volatile matter and passes through the ignition zone and then enters into the region of incandescent coke. The air mixes with the formed of volatile matter. The air mixes with the air mixes with the volatile matter and passes through the ignition zone and enters into the incandescent zone, then enters into the region of incandescent coke. See, coming to the second point, the reactions which takes place in the incandescent zone of underfeed stroker are very much similar as the feed incandescent zone of overfeed stroker. See here, the reactions which takes place in incandescent zone of underfeed stroker are very much similar. It is similar to that of a feed incandescent zone of overfeed stroker. The third point which we can study here is about the gases coming out of raw fuel bed passes through a region of incandescent ash on surface of the fuel and finally discharged to the furnace with the constituents like overfeed stroker. By using of this overfeed stroker, we are going to pass these fuel onto the surface. And coming to the fourth point, the supply of secondary air is required in the case as the gases coming out of the fuel bed also contain combustible matter. Here, for the gases which is not burned clearly, we can by using of this secondary air, we are going to burn these gases, and we are going to get the heat here for burning the feed water and for converting the feed water into the for getting superheated steam or saturated steam in the boiler. This is what which we have studied in this lecture about the properties of coal and overfeed and underfeed of fuel bloods. I think you can understand these properties of coal and overfeed and underfeed fuel beds very carefully. Thank you. If you have any doubts, please contact me or you can mail to this mail ID. Thank you.